everyone, and welcome to a new series on a new channel. In this series, I'm going to be creating a custom game console, including making my own games, my own controller, and potentially the entire console that it runs on, using parts that anyone can buy. For this first video, I wanted to start on the core components of the game. This first game is going to be a game that takes place in an arena with some sort of item that you can collect and modify and upgrade over time. I haven't figured out the specifics, but that's the core concept. So in order to start with that, I needed to create. With that goal in mind, I'm going to try and expand the screen a little bit. With the screen expanded, I will show a time lapse of my process up there. The first step was to actually model the arena, and I just chose to use Blender for that because I've used it before and it is free, open source, and just overall a wonderful tool. As you can see from the video, I'm starting with just a basic plane, and then I add some edge cuts to basically give it the program more data to work with to change the shape of the plane. I also scale up the plane about 50 times. I had initially assumed that by switching the units to feet, the base plane would start at 1 foot by 1 foot, such that scaling it up by 50 would make it 50 feet by 50 feet. Looking back at that, I believe that assumption was incorrect. I am actually dealing with something that is 2 meters by 2 meters times 2, except all of the units are dealt with in feet. So it's a little bit weird in terms of like an actual real life scale, but it's a video game. It's not real life. It'll be okay. I also made sure to make all of the walls to contain the player 10 feet tall. Again, I don't think that's actually feet, but it's tall enough that it's hard to get out of. Eventually there might be some mechanic I add that makes it possible, in which case I'll have to come back and add like a roof. I'm sticking to a rule of thumb of 3 spaces for any sort of narrow walkway. That will make sure that it's easy to fit between 2 spaces. Anyone that's played Minecraft knows like trying to stand inside a cauldron is really hard. I'm trying to avoid something like that. And I'm also adding obstacles to the arena such that if it's PvP or PvE, there are still places to hide, as well as higher vantage points to see more of the arena. Once I finished modeling everything, I exported the FBX model from Blender into Unity. That was the 3D model format that Unity accepts. I later found out I can also just import my .blend file, which is the way Blender stores projects. I did eventually switch over to using the .blend because of texturing and using the UV map, which I will explain in a sec. Once I had the arena imported into Unity, I then added a character, which was, in this case, just a simple capsule. I'm using capsule because at the moment I don't want to worry about rigging player and working on animations, because animations in Unity can be somewhat tedious, but down the line I might add that. I also kind of like the idea of just a bunch of capsules running around a giant arena doing things. I think that could be kind of funny. It also makes it easy to tell like which team, if I add that, which team any player is on, because the capsule is just a solid color. There's no way to really hide what team you are, which could be beneficial. With the movement, I was just following a tutorial from Brackeys, which if you haven't tried Unity but want to, Brackeys has some great tutorials. They are starting to get a little bit outdated, but most of the fundamentals stay the same. Once I added movement, I ran into a little bit of a weird bug with the arena, as you can see on screen right now. Basically, parts of the wall were not collidable, and because of that, you could walk through and see through parts of the wall that you shouldn't have been able to. However, depending on how it was structured, sometimes you would just get stuck. In order to understand this normals bug that's letting you phase through walls and making like kind of non-Euclidean geometry, the thing that you need to understand is a little bit of calculus. Now, that might sound intimidating. It's not as bad as it sounds. Basically, you can create a plane or a 2D surface in 3 dimensions by using a series of points, or you can just use a few vectors. A vector is something that has magnitude and direction, just like the villain's in Despicable Me. To represent vectors for the purpose of this demonstration, I'm going to use 2 maroon mallets. Vector A will be this blue mallet. Vector B will be this whitish gray mallet. Let's say the 2 vectors sit in a space like this. So the plane would be like this. Now, which side of the plane is the top? That's what will determine whether or not you collide with it if you hit the top. You can calculate which way this goes by doing the cross product, but the cross product is really gross and I'm not going to mess with that. The easiest way to figure it out is to go from vector A to B following the right-hand rule. You can think of it in 2 ways. Either your pointer finger points in the direction of A, your middle finger points in the direction of B, and then your thumb thumb points in the direction of the plane, or in this case, what's called the normal of the plane. Now, this is incredibly uncomfortable to hold. So the way I prefer to think about it is going from vector A to vector B and rotating your hand that way. Whichever way your thumb points is the direction of the normal. Now, we can go from vector B to vector A. In this case, right-hand rule tells us the normal vector points the opposite direction, thus changing which side we would have to collide with the plane in order for it to actually stop us from moving. That is what is happening with this current bug, and that is why all you have to do is go into Blender and flip the normals. Once I worked on adding jumping to the game, I found that the ground detection was not working for some reason, and so I did a bunch of digging. For some reason, the only values that would work properly were basically saying if there's anything within negative 0.2 Unity units, then touching the ground, which in a physical sense, which is what Unity tries to model, makes zero sense. So clearly something was wrong there. It took me a while, but I did eventually find a fix. It is not, I don't have a clip of it in the time lapse, but you'll see a clip of it in the final playthrough. It was basically that check sphere function was also finding the player that it was attached to. So it was always saying, yeah, you're touching the ground, even though it's actually just the player's in contact with the player. Once I added a layer to ignore of the player, everything seemed to work properly. Once I had basic movement, I wanted to make it easier to tell where you were on the map, so I wanted to add textures. For this, I went back into Blender and added some textures. I followed Blender Guru's texturing tutorials for doing a whole bunch of different stuff. He has a 2-hour-long tutorial linked in the description that was super helpful for figuring all of this out. This basically let me apply textures that I found online to the arena such that it's not just a solid color. I could actually have a rusty metal color, or eventually I turned it into like a dark gray slate color. For a couple other spots in the arena, like the walls and a couple spots where I wanted a mirror, I ended up using something slightly different. I just had a color texture and then added noise to it in Blender such that there would be some variation. It wasn't just a perfectly smooth color. Once I had all the texturing done, my next task was to be able to apply it in Unity. Every tutorial I found on that was saying to use Blender's built-in texture bake. Alright, so I'm currently in the process of editing this video, and I realized I didn't exactly explain UV unwrapping or what baking is, so I'm going to try and do that right now. UV unwrapping is basically taking a mesh, which is a set of planes or vertices, which are just points in 3D space, and converting it into a 2D mapping such that an image, which is usually 2D, can be applied to it. Think of it as taking a cube and unwrapping each face, and then you end up with 6 faces, and you can set them on an image, and each face gets its own section of the image. The other thing is texture baking. Texture baking is the process that takes the textures that are already on a mesh or some object and applies them to a 2D image. In the case of what I did with this project, I took all of the textures and baked them together into one, including all of the metallic textures, all of the diffuse textures, all of the emissive textures, etc., and put them into one. Because of that, I ended up with some weird shading that doesn't quite behave how I want it to. So I found a tutorial for that, also linked in the description. Following that tutorial, I figured out the rough settings, which you can see me applying here, and I created the blank image node that everything should end up baked onto. However, every time I tried to render, Blender was between 60 and 100% done, it would crash. I don't remember how many times it crashed, but there's a compilation up there. I think it's 5 or 6 though. I was about to submit a bug report even after trying it on a different operating system, and then when I was filling out the bug report, Blender wants a simple blend file to reproduce the bug. So I set up a texture bake there, and for some reason it worked. That told me that it wasn't Blender that had the issue, and it was something the way I had set up the projects. The issue was that the blank texture node that I had to bake the image to had to be on all of the textures that I wanted to bake, not on a new texture to bake all of them into one. Once I had that fixed, I was able to do the bake, and it only took a minute or so if I remember correctly, and then I was able to apply it to Unity. I didn't get a clip of that. I was working on a different operating system at the time that didn't have screen recording working. but you'll see it in the final playthrough. I will be going just through a decent chunk of the map, take a look at some of the textures. Because I only used an image that was 2048 pixels by 2048 pixels, there is some pixelation in the textures, so I need to do it at a higher resolution, and it is all matte. The reflections that I wanted and that I saw in Blender did not transfer. Probably means I need to bake textures based off the different types of materials. Additionally, there are still a couple normals that I did not get reversed because I hadn't seen them when I had done most of the normal reversing, so I will also be showing that bug in more detail than you could see from the time lapse. In-depth question, I might just add it to my next video. Speaking of which, the next video I'm planning to add custom controls based off of hardware input. So stay tuned for that, and I will see you next time.